So now let's look at how we can convert these with matrix into matrix systems. So I'll look at the first one and I will try to rewrite it. I'll try to rewrite it with only in standard form. So we have x double dot is equal to negative k1 over m1 times x1 plus k2, that k didn't come out well, k2 over m1 multiplied by x2 minus x1. Okay, so now the game is to re-express this such that we have just first derivatives. So let's say that x1 is equal to y1 and that x2 is equal to y2. And let's distribute this. So this is going to be negative k1 over m1 times x1 plus k2 over m1 times x2 minus k2 over m1 times x1. So now we can group these two together, and I'll do it over here. So I'll move this down and I'll have color-coded minus k1 m1 minus k2 m1 times x1, and then we have plus k2 over m1 k times x2 times x2. Okay, so now we redefine what x is, and I want to take the derivative of these two. So here I'm going to say derivatives, and we're going to get x sub 1 prime or dot is equal to y1 dot, and here I made a mistake. I want it to define x2 as the derivative, because this is x2 is equal to this. So the derivative of x2 is equal to y2 like this. I take the derivative of this again, and I see that double derivative is going to be equal to y double prime of 1. What is y double prime of 1? Well, let's say that this is x1 dot of y2. So y double prime x double prime of 1 is equal to y prime of 2. And I know here that this is equal to y2, and this is equal to what I have over here. Copy, paste. So now I can rewrite this whole thing by looking at derivative and original thing. Now I have to redefine these two. So I have to say that x1 is equal to y1, so that It's going to be here, y1. And x sub 2 must be equal to some other y. X sub 2 must be equal to y3. So we'll put that this is y3, but we'll have to remember that for later. Okay? So now we have this first part of the system, y1, y prime 1 is equal to y2, and y2 is equal to y prime. And now we want to do the same thing for the other two systems. So let's go with the second one. The second one right there, we're going to distribute. So we're going to divide by, and here I forgot to put the subscripts. So this is 1, this is 2, and this is 3. These are important because we're distinguishing them. So here, we're going to have 2, which is going to be equal to negative k2 over m2 times x2 plus k2 over m2 times x1 plus k3 over m2 times x3 minus k3 over m2 times x2. So now we can group them together, and we can say that that's equal to minus k2 minus k3 over m2 times x2 plus k2 plus k3 over m2 times x3. And now we can say, okay, let me say, we already nominated x2, so we're going to reiterate that x2 is equal to y3. Then we're going to say that x3 is equal to y4. Well, no, let's say that x double dot of 2 is equal to, not double dot, x dot of 2 is equal to y4, and that x3 is equal to y5. And then we're going to say, we're going to take the derivatives of this, and we're going to say that x dot of 2 is equal to y dot of 3, which is equal to y4. And then we're going to say that x double dot of 2 is equal to y4 dot, which is equal to negative k2 plus k3 over m2, all multiplied by x2, which we said is y3, plus k2 plus k3 over m2, all of that multiplied by x3, which is y5. So now we have this system, which is interesting. And now we need to have one more. So let's do that. Let me separate this and put separation here as well. Now we're going to say m dot 3, nope, x double dot 3, looking over there, is going to be equal to negative k3 over m3 times x3 minus x2. So that's going to be equal to negative k3 over m3 x3 minus k, or plus k3 over m3 times x sub 2. So now that we have this, we're going to say, reiterate that x3 is, well, we said earlier that x3 is y5. x2 we had already define that as well. x2 is y3. So now we take the derivatives. And what we get is that x dot 3 is equal to y dot 5, which is equal to, well, we haven't defined that. So let's say x dot 3 is equal to y 6. So now we have that this is equal to y6. And now x double dot of 3 is equal to y prime of 6, which is equal to our expression over there, which is negative k3 m3 times x3, which we said is y5, plus k3 over m3 times x2, which we said is y3. And now we have these two interesting equations. So now, look, we have 6 equations. Let's try to rewrite these, and let's see where we get. So I have y prime 1 is equal to y2, and y dot 2 equals to the negative of k1 plus k2 over m1, y1 plus k2 over m1, y3. Then we have y dot 3, where is y dot 3, is equal to y4, and y dot 4 is equal to negative k2 plus k3 divided by m2 times y3 plus k2 plus k3 divided by m2 times y5. And then we have y dot 5, which is equal to y6, and y dot 6, which is equal to negative k3 over m3 times y5 plus k3 over m3 times y3. So now the left-hand side looks pretty good. The right-hand side, we need to make some adjustments. So we want to align all the y1s. Well, we only have one y1. And then we want to align the y2s. So let's say here we put y2. Do we have any other y2? No, we don't, but we do have a y3. So I'll move the y3. Move the y3 here. No, we have a y4. We do have a y4. So this, we can move it over here at y4. And then we want to do y5. So let's do y5. We'll move it over here. And then here we have another y3. Don't forget that positive sign here. Maybe that y4 goes a little bit more over here. And then this is y3 with the negative sign. That's going to move right here. y2 can be moved here. y6 goes all the way down here. And then we have y3, which can be put right here. y5, which can be put right here. Now, we fill up the rest with 0. So we have 0 y1 plus 1 y2 plus 0 y3 plus 1 y4 plus 0 y5 plus 0, y6. Here we have y1 plus 0, y2 plus 0, y4 plus 0, y5 plus 0, y6. Here we have 0, y1 plus 0, y2 plus 0, y3 plus y4 plus 0, y5 plus 0, y6. And then we have here 0, y1 plus 0, y2 plus 0, y4 plus 0, y6. Here we have 0, y1 plus 0, y2 plus 0, y3 plus 0, y4 plus 0, y5 plus y6. And here we have 0, y1 plus 0, y2 plus y3 plus 0, y4 plus 0, y6. So now from this, we can actually write it in matrix form. So I'm just going to copy this, copy it, and I will paste it over here. And now I'm just going to erase these and the signs if they're positive. And this is going to represent a matrix. Oh, I want to leave the 0 there. Leave the 0. That goes away. And then this stays 0. Leave the 0 there. There, like this. Like this. Here we need a 1. Here we'll leave the 0. Here again, we got these zeros. Right here. Get rid of these signs if they're positive. That goes away. And I'll show you in a second what we do with the y's. And then this will go away. The positive goes away. This goes away. Like this. Now I can write this into a matrix, but I need a little more, I need a little more space here. So I'm getting all of this and I'm moving it over here. Then I'm going to put this in a matrix, put this in a matrix, like that. I'm gonna have to redo the equal signs. That's better than rewriting the whole thing. So we'll equal, well, we just need one equal sign now. So this is going to be equal. Now here, I'm going to put all of this in a matrix. And this becomes a nice matrix. Okay. And then here I'm going to write another matrix with all those original variables. So here, let me make some open space. And here we get y1, y2, y3, y4, y5, y6. Now, which ones were the one that we were used to? We were interested in? Well, we were interested in x1, which is y1. So we're interested in this function. Then we're interested in x2, which is y3. Interested in this function. And then we're interested in x3, which is this function over here. The other ones are, as you see, their velocities as we have defined them. So I hope this was useful to better understand the modeling for this particular problem, and I will see you next time.